that is sliding, rolling and fluid or air resistance. They three are example of dynamic or kinetic friction. Its coefficient is noted by mu d. Mu d is equal to force of friction, kinetic friction divided by normal force. Mu d is coefficient of dynamic friction. F normal is normal force. F friction is force resisting motion. It has been found experimentally that mu d is always less than mu s. Mu d, that is coefficient of dynamic friction, it depends upon relative speed of the surface. At speeds from 1 centimeter per second to several meter per second, mu d is always constant, so it does not vary much, but it is always less than coefficient of static friction. Next we come to some applications of friction, physics of car tires. The magnitude of static friction acting on the rubber tire on the road surface, it depends upon coefficient of friction and the surface area of contact. Since the race tires have no threads, so races are sometimes postponed due to rain because they have no thread, no friction, but in rainy season the friction already becoming less. So the race cars use wide tires to increase the surface area and to prevent slipping through curbs. So if we want to prevent our cars or the race cars from slipping, then its contact area should be more with the surface, so their tires are wide as compared to ordinary vehicles. Next example is on the wet roads, traveling at low safe speed allows time for the water to move through the grooves, but if the driver speeds up, the water starts to build up in the front of tire, so it causes the tire to lose the contact with the road, so it leads to the less friction and leads to accident. Next example is controlling friction, how we can control the friction. The soles of the hiking boots and athletic shoes, here we can see that to make the friction less, then the hiking boots and athletic shoes, they are made like this: artificially joints, skate and bobble design, and under and over inflated tires. Next we repeat the previous slides. Static and kinetic or dynamic friction. Static friction comes into play when the body is not sliding, that is nothing is happening, body is at rest. Sliding frictional force comes into play when two surfaces are sliding with each other. And third, last is static frictional force is always greater than sliding ones. There are 5 main types of friction. Sliding friction, its example is ice skating. Second type is rolling friction, its example is bowling. Third type is fluid friction, in air or in liquid in water, that is air or water resistance. Fourth type is static friction, that is if the body is not moving, initial friction when the body is moving, before the body is moving. And kinetic friction comes into play when the body is in motion. These three, sliding, rolling and fluid, they are part of kinetic friction. This is same example of book. So here we can easily see pictorially that if the motion is in this direction, force of friction is in opposite direction, so at the point the limiting friction becomes maximum, so after that limiting friction decreases. So force that acts opposite to the relative motion of the two surfaces, that is called force of friction. It is high for dry and rough surface. If the surface is rough or dry, then force of friction is high, but if the surface is smooth or wet, then the force of friction is less. This I have already explained. This is free body diagram. If the body has mass m, then this is called weight, which is acting downward. So this is gravity force Fg or weight, and normal force which the earth exerted on this body is called normal force. It is always perpendicular to the surface. So if the applied force is in this direction, then frictional force is in opposite direction, in this direction. So Fg, this force or weight, is equal to mass into gravity, acceleration due to gravity, and Fn, so Fn is equal to Fg, and applied force is equal to Ff. So 2 points here, that this force is equal and opposite to this force. This force is equal and opposite to frictional force. Here we pictorially define static friction if there is no motion between the two surfaces, sliding friction if the body starts sliding. Third one is rolling friction, like the tire of the car or a scooter. If the body is rolling like this, then the friction comes into play is rolling friction. Fourth type is air friction or viscous friction, like the motion of a helicopter or the aeroplane in the air. So the friction acting here is called air friction. So if we can take example of ship or the so the here the friction comes into play in the water or in any liquid, that is called viscous friction. Kinetic friction comes into play when the body starts moving. Here the example of kinetic friction. Next we completely define the air resistance. Air resistance is a type of friction between the air and another material when an aeroplane flies through the air. For example, air particles hit the aeroplane, so making it more difficult for the aeroplane to move through air. So here the friction comes into play is called fluid friction, or you can say air resistance. So the some shapes known as streamlined shapes causes less air resistance than other. Aeroplanes and car, they are streamlined so that they move through the air as easily as possible because it reduces the friction. Next is fluid friction. This type of friction is what happens with the liquid or gases. In physics, liquid and gases, they are both called fluids. They behave in the similar way. Fluid friction is also known as drag. On aircraft, it is also called air resistance. It depends on the following factors: how thick the fluid is, that is its viscosity. More its viscosity, the more will be the fluid friction. Second, it depends on the shape of the object, that is area of the contact. And third, it depends on the speed of object. This is example of numerical of the force of friction, how we can calculate force of friction. A 10 Newton force is acting on this body, 10 Newton force acting on a body. It pushes down a box and its weight is 100 Newton. As the box is pushed horizontally in the horizontal direction, the coefficient of sliding friction is 0.25. So we have to determine the force of friction resisting the motion. So we know formula, that F is equal to mu into Fn. Mu is coefficient of friction, Fn is normal force. So we know total force acting on a body is 100 plus 10, so 110 Newton. So the force of friction is equal to mu into Fn, 0.25 into 110, so it is 27.5 Newton. Next is magnitude of the frictional forces. Maximum force acting on a body, frictional force is mu s into n, where mu s is the limiting friction, n is normal force. So it is independent of the normal forces and the area of contact. Mu is independent, this mu is independent of the normal forces and area of contact. The general case for the equilibrium condition is F is always less than mu s into n. Once the body starts to slip, then this force is equal to mu k into n if the body starts moving. So mu k is called coefficient of dynamic friction, and mu k is always less than mu s. It is found experimentally. So friction, if the friction is high, means load of friction, so it will slow down the body. But if the friction is less, so it will keep things moving. Opposing force and application of forces. Here we do the application of frictional forces. Friction, it is a force which acts opposite to the motion. It is caused by the irregularities in the surface in contact. That is, if the surface is rough, then force of friction is more. Its amount, it depends upon the material involved. So the force of friction, it depends upon the material. It occurs in fluid as well as in solids. It depends upon viscosity in the liquid. More viscous the liquid is, then the force of friction will be more. And it depends upon air resistance in the air. Friction also causes the need for the applied force to keep the constant velocity. Next we come to the applications of the force of friction. First one is walking. We cannot walk without the friction between your shoes and the ground. As you try to step forward, you push your feet backward because the friction is less. Friction holds your shoes to the ground. It allows you to walk. Consider how difficult it is to walk on the slippery ice where there is less friction. So we can conclude here that without friction we cannot walk. On the icy surface there is less friction, so we cannot walk on the ice. So we have to reduce the friction. Second example is writing. Writing with a pencil, it requires friction. We cannot hold a pen in our hand without friction. It would slip out when we try to hold it to write. The graphite pencil lead won't make a mark on the paper without friction. That is, we cannot write without friction. Another example is a pencil eraser also uses friction to rub off mistakes written in pencil lead. Rubbing the eraser on the lead wears out the eraser due to friction, while the particles worn off gather up the pencil lead from the paper. Third example is application of frictional forces driving car. Your car would not start moving if it was not for the force of friction between the tires and the road. With no friction, the tires would just spin. Likewise, we could not stop without friction of the brakes and the tires. If there is no force of friction between the brakes and tires, then we cannot stop our vehicle. Next example is makes movement difficult. Anytime you want to move an object, the friction can make the job more difficult. Excess friction can make it difficult to slide a box across the floor. If there is more friction between the box and the floor, then it is very difficult to move. So an automobile would not move forward very well unless its friction was not reduced, and the oil is needed to lubricate the engine and allow its parts to move easily. Oil and ball bearings, they are used in the wheels so that they will turn with little friction. Next is, it wastes energy. We already know the force of friction produces heat. So in any type of vehicle such as car, boat or airplane, the excess friction means that extra fuel must be used to power the vehicle. So in other words, fuel or energy being wasted because of friction. Fluid friction or air resistance, they can greatly reduce the gas mileage in an automobile. Cars are streamlined to reduce friction, but driving at highway speeds with your window open can create enough drag on the car to greatly reduce your gas mileage. Heat parts. Next application is heat parts. The law of conservation of energy, it states that amount of energy remain constant. It cannot be lost, it cannot be gained, but it can be converted into one form to another. Thus the energy that is lost to the friction in trying to move an object is really turned to the heat energy. The friction of parts rubbing together creates heat. You have seen how people will try to start a fire by vigorously rubbing two sticks together, or perhaps you have seen an automobile spin its wheels so so much that the tire starts to smoke. So there is more friction. So this friction convert into heat part. These are the example of friction creating heat energy. Just rub your hands together to create the same effect. It wears things out. Any device that has moving part can wear out rapidly due to friction. Lubrication is used not only to allow parts to move easier but also to prevent them from wearing out. Some other examples of material wearing out due to friction include the sole of your shoes and pencil eraser. Here the one quiz. Sand is often placed on an icy road because the sand decreases the coefficient of friction, or it increases the coefficient of friction. It decreases the gravitational force on the car, or it increases the normal force. The correct answer is B, that is, it increases the coefficient of friction between the tires of a car and the road on the icy surface. Thank you.